All right, we're now going to talk about comets. Comets are made mostly of ice. That's when I mean ice, I mean water ice. Remember, water is a very common molecule in the universe, and these are just chunks of ice. You're like, if they're chunks of ice, why do they look so cool? All right, so we're going to talk about that. Let's talk about Comet Halley first. Remember I told you Halley, Edmund Halley, he was around when Newton was around. And he was the one that went to Newton and convinced Newton to publish his work. He was also the head of the Greenwich Observatory for a while. But he was looking through historical records and he realized that there was a bright comet in 1531, 1607, and 1683. And he talked to Newton and they realized it was the same comet, and these comets have very eccentric orbits. They're not on circular orbits at all. And so he realized then that this was the same comet, and that Comet Halley came back about every 76 years. 76 years. And the last time it was 1986. Long before most of you were born. I saw it. It wasn't very spectacular. It's because of where it was in its orbit relative to where the Earth was in its orbit. It wasn't very good at all. But in 1910, it was really spectacular. So what happened is, here's the sun. Here is Halley's Comet. It comes around like this. Well, this is the way all comets work, and here's like the Earth's orbit right here. It actually goes inside the Earth's orbit. Okay? And then it goes all the way out past Neptune's orbit. So a highly eccentric orbit, 76 years. Well, when it comes in here, since it's a ball of ice, what happens is, once it gets close inside, about to just before it gets to Mars's orbit, that's when there's enough solar radiation to start melting the ice. And once it melts the ice, we start to see this. So what we have is this chunk of ice, we call that the nucleus. So this is comet parts. And then that ice starts to melt and it creates this cloud of gas around it. As all that melts, remember it doesn't go to a liquid, it goes directly to a gas. And all those particles start to completely encircle it because there's not enough gravity and there's no air friction in space. So it just creates a spherical region around that. We call that the coma. And then off the coma, then we can get tails. And we get a tail that sometimes curves away. This is called, and I should be doing it in a different color, this is called the dust tail. It's usually white because it's mostly made of dust and ice particles, and it reflects the light very well, very bright. But we can also get a very narrow tail coming off. We call that the ion tail, because it's made of charged particles. If you strip the molecule of its electron, then it'll have a charge, and this will always point away from the sun. So the sun is this way, so the sun's solar wind is always pushing the tails behind it. So no matter where it is in its orbit, the tails always go away from the sun. Okay? And the ion tail always goes exactly away from the sun because it lines up with the magnetic field. Alright, so what happens is, with Halley's Comet as it comes around, it starts to get inside here, it's going around this way, it has a tiny tail, and then as it gets closer to the sun, the tail starts to get really big. And when it hits its perihelion point, remember when it's closest, it's perihelion, it's got its maximum tail, then it gets thinner, and then when it gets outside about Mars' orbit, it all freezes again and just becomes a chunk of ice floating around the sun. So the tails always point away from the sun. A lot of people think the tails are pointing away from the direction it's moving, that it's moving this way, makes the tail go that way. That's not the case. It could be moving this way and have its tail going this way too. Okay, so it's more the solar radiation that that makes the tail point that direction. All right, so back to Halley's Comet. In 1910, when Halley's Comet came by. The Earth happened to be right over here, and the Earth went right through the tail of Halley's Comet, which was pretty cool in 1910, if anybody was still around then. 1986, we were over here when the comet came by, and so we barely saw it. We did not hit the tail at all, and so it was very low in the sky. When I saw it back in 1986, that was like spring break. I was going to school in Montana, and I took a road trip from Montana down to Arizona because you couldn't see it in Montana, it was too far north. Went down to Arizona so I could see it. Got up at 4 in the morning. I could just barely see it above the horizon. I could see this little fuzzy thing out there. I'm like, okay, that's exciting, and I went back to sleep. It was not very exciting. But I did see Halley's Comet, and that was pretty much. I did it just to see Halley's Comet, and I went and saw the Grand Canyon at the same time, which was really cool. All right, 1986. When's the next time it's coming? Well, if you add that to it, you get 2062. So, put it on your long-term calendar, it'll be back. All right, let's look at some pictures here. This is Comet Ayakataki. This was in the 1990s, I think around 1996. In fact, I think it was exactly 1996. Comet Ayakataki was found by a Japanese guy. If you discover the comet, you get to name it. Or usually it's named after the discoverer or the first two people discover it, if two people discover it close together. Comet Ayakataki was found by this Japanese guy. This one has a long blue ion tail, but almost no dust tail. So they can vary. This is still the coma down here. You can't see the nucleus at all. We can't see the nucleus from Earth ever. The coma covers that up. It's opaque, you can't see through that. The cool thing about Comet Ayakataki, it wasn't super bright, but the tail was really long. I was living in Georgia at the time, and I went out to see it, and I could see it out in the west, and the tail stretched almost 90 degrees behind it. So that the angle between that and the top was about 90 degrees. So it had this huge, long, tiny, thin tail. It was gorgeous. It came real close to the Earth. Well, relative, 1 million miles or so. Then later, just like 2 years later, came Comet Hale-Bopp, which was named after the two guys that discovered Mr. Hale and Mr. Bopp. This one's classic because you see here's the dust tail, here's the ion tail, the blue tail right there. Where's the sun? Well, the sun has to be exactly down here. Remember, it's exactly opposite the ion tail. This one was really bright. The tail wasn't as long, tail was only a ways, but it was a super bright comet. You can see it's brighter than all the stars. I was in downtown Atlanta one night picking up an airplane at about like 2 in the morning, and I could see it between the buildings with all the streetlights and everything in downtown Atlanta. I could still see the comet. It was that bright. Surprised me. I thought, oh, there's no way, because usually you can't even see a single star when you're down there. But it was very bright for a short while. Now, this one has a huge orbit, meaning it's not coming back for about 3,000 years. So you'd have to put it on your super long-term calendar if you want to see that one again. This is a GIF showing following a comet over time. Notice how the tail wavers back and forth. This is a very small comet. Those are clouds going through. You see that white there. So the telescope just followed this comet all night long. But you can see that the tail wavers along with not a nice straight line all the time. It actually wavers and kind of breaks apart as you get out here if you watch it close. Yeah, it's a cool picture. All right, when Halley's Comet came in 1986, they said, hey, let's send spacecraft so we can actually see the nucleus of comet. Since then, we've done that for many other comets, but Halley's was the first. So they sent spacecraft that flew through the coma. The coma is actually really low density. You can fly right through it with a spacecraft, doesn't hurt it, okay? But they did, and they found this is the nucleus of Halley's Comet. What surprised them was, they thought it was more like a snowball, and that the ice was melting all over, but no, the ice only melts off in very specific places. The rest of it is covered in very dark carbon. Sound familiar? We think maybe that those asteroids that we call carbon asteroids are not really asteroids at all. They're actually comets in which the outside of the comet, the ice got covered by so much carbon that it can't melt anymore. If it can't melt anymore, then we don't call it a comet because it doesn't produce a tail or any of the other things you see from a comet. So, the C-type asteroids are more icy as the S and the M ones are rocky and metal. So the C-type asteroids seem to have come from a further distance. In fact, we think that the asteroids, the main part of the asteroid belt, the rocky parts, were formed between Jupiter and Mars, but the C-type asteroids were actually found further out. But then early on in the solar system, Mars and all the planets kind of shifted around over millions of years, shifted their distances, and some of those outer ones got mixed in with the asteroid, and that's where the C-type came from, was from the icy bodies that are further out beyond Jupiter. All right. This is another comet that they've got the nucleus. This is the nucleus, comet Hartley 2. You see, it's only actually melting in very specific spots. The rest of it is covered. Essentially, it's covered in this dark material that keeps it from melting. It's like covering it up with mud. And we have more. This is Temple 1. And you can see how, if we took this away right here, that looks just like an asteroid. It's just the inside is ice instead of rock. And here's a comparison of the different ones. All right, and this was Halley's Comet back in 1910. Now, I'll tell you an interesting story with that. I told you that the Earth actually went right through Halley's Comet's tail back in 1910. And back in 1910, remember, it was still, well, actually, I don't know if it's any different nowadays, but it was easy for people to make stuff up that wasn't scientifically true. Same problem we have nowadays, people that just don't base any of their ideas on any kind of science or logical thinking. Well, they would claim, there were people that would go to these small towns and claim, oh no, we're going to go through the tail of the comet, there's all these noxious gases that's going to enter our atmosphere, and everybody's going to die. So they got everybody panicked, but they said, but if you buy my magic pills, it'll keep